Hey there, in this video we're going to go over the systems test review. Now, since the assignment is on ALEKS, the problems will be similar but not exact, but hopefully it gets you an idea of what you're doing on each question and kind of maybe the ins and the outs of how to do them. If you have any questions, please make sure you send me an email so we can either set up a Google Meet or I can answer your questions that way. And here we go. So, systems test review. Question number 1 on your test review is going to ask you to identify solutions. So remember, I have 3 different types of solutions. And remember, a solution is whenever 2 lines, wherever that single point that are on both lines. So if I'm looking at system A, there is not just a single point. You see L1 and L2 are signifying that my lines are stacked on top of each other. So they're crossing not just at one point, but every single point. That means I have my solutions are infinite. The system has infinitely many solutions. Part B, I notice that the lines are parallel. These lines never cross. So never is it going to be that one dot is on both lines. So on this problem, part B, I would say there is no solution. Part C, now as I see these 2 lines, I can see that they cross in exactly one place. Only this dot is both on line 1 and on line 2. So how do I tell how do I tell my solution or what my solution is? Okay, I find the x and the y value. So the x value of this dot is -2. The y value is +2. And there's my answer for question number 1. All right, question number 2 is going to have me investigating a graph. So on this graph, I notice that I have 2 plans. So it says Susan can choose plan A or plan B for her long distance charges. Each plan in dollars depends on how many minutes per month as shown below. So I've got this plan A versus plan B, and I can see at the beginning plan A charges 0, plan B charges 8. The first question says, if Susan makes 120 minutes of long-distance phone calls for the month, which plan costs less? So let's investigate. At 120 minutes, plan A costs, well, what's the cost? $12. Plan B charges $14. So they're pretty close in cost, but not quite. So plan A, which plan costs less? Plan A costs less. And how much less does it cost? Well, 14 minus 12 is $2 less. And then the second follow-up question, for what number of long-distance minutes do the plans cost the same? Well, the cost is the same at this value right here where the 2 dots intersect at a value of $16. For what? The question, make sure it says what number of minutes. So I want to make sure I don't write down 16 because that's the cost, but how many minutes? 160 minutes. The last question says, if time spent on long distance call is less than this amount, so if I spend less than 160 minutes on the phone, which plan costs more? Okay, plan B costs more if I'm talking less than 160 minutes, because I can see plan B is above plan A. The next type of question you're going to see, questions number 3 and number 4, are going to look like this. It says, for each ordered pair, determine whether it is a solution. So in order to test, I'm going to test each and every single point in my equations. Remember, the first value is an x. The second value is y. So when I'm testing it, I take 0 and I plug it in where the x goes, but make sure I put some parentheses if it's next to something. And then I put the 1 in for y. So what does that look like? 1 equals 2 times 0 plus 1. Well, let's simplify. 1 is equal to 2 times 0 is 0 plus 1 is 1. So it works out for the first equation. But remember, I'm not just going to click yes until I test it in the second equation. So plugging in the 0 for x, plugging in the 1 for y. So -5, and remember I plug them in parentheses. So -5 times 0 plus 3 times 1 equals 8. -5 times 0 is 0. 3 times 1 is 3. 3, 0 plus 3 is 3. Does that equal 8? No, it does not. Now, because it's not on both lines, because it's not a solution for both lines, the final answer is no. Let's test point number 2. So point number 2, I'm going to plug in 5 for x and 11 for y. So 11 is equal to 2 times 5 plus 1. Well, 2 times 5 is 10. 10 plus 1 is 11. So 11 equals 11. This first one works out. Let's test it in the second. So when I plug it in the second, negative 5 parentheses 5 plus 3 parentheses 11 equals 8. Let's see if it works. Negative 5 times 5 is negative 25. 3 times 11 is 33. Negative 25 plus 33. Let's just do a quick double check. Negative 25 plus 33 is 8. So I do. 8 equals 8. So it does work for both equations. So my answer on this one is a yes. Testing for my last two. Negative 7 in for x, negative 9 in for y. Negative 9 is equal to 2 times negative 7 plus 1. That gives me negative 14 plus 1, which is negative 13. That is not equal to negative 9, so this is an automatic no for the first one, so it's no overall. And the last one, 3 and negative 2. 3 in for x, negative 2 in for y. So negative 2 is equal to 2 times 3 plus 1. 2 times 3 is 6, plus 1 is 7. 7 does not equal negative 2, so that one's out as well. So that solution is out. So that's what 3 and 4 look like. Hey, test those ordered pairs, and there we go. All right, questions 5, 6, and 7 are all going to follow this format. They're asking me to, here's a system, find the ordered pair solution. So I'm going to graph each line separately. So remember, ignoring the second one. The negative 4 gives me my start. So start at negative 4. And the 2 tells me, remember 2, make it a fraction. 2 tells me to go up 1 and over 2. So taking all this information, start at negative 4. And then I'm going to move up 2 and over 1. And I'm going to plot my graph. Now let's plot our second one. Now we have to focus on that second line. So if I'm looking at this one, my start at 2. What number is that? Well, it's a negative 1 because there's not a number there. And I'm going to make it a fraction, negative 1 over 1. The negative 1 tells me to move down 1. The positive 1 tells me to move to the right 1. So let's put all that information together. Start at 2, move down 1, and to the right 1. When I extend my lines, I can see that they cross right here at the ordered pair 2, and the y value is 0. Let's just check one more to make sure we've got the hang of that. So on the first equation, start at 4. This slope is 1. Remember to turn it into a fraction. Positive means move up. Positive means move right. So put that information together. Start at 4. Move up 1 and over 1. And I'm going to extend my line on that one. Now graph our second one. Start at negative 2. And my slope is negative 2. Make sure it's a fraction, negative 2 over 1. So I'm going to move, because it's negative, down 2 and to the right 1. That positive 1 on bottom always means I'm moving to the right. So I'm starting at negative 2. I'm moving down 2 and to the right 1. Now, right now, it doesn't look like my lines are going to connect because it's going down. But if I extend my line by using my tool, I can see that they cross right here at the ordered pair. Negative 2, 2. And that's my solution. Now the last problem on your review is going to look like this. So I'm going to graph the system below and write its solution. Now, remember to focus one equation at a time. Now, this top one does not say y equals something x plus something, so I need to solve for y. I'm going to write this out to the side so I can do that. Negative 2x plus y equals 6. Remember, I draw my line down my equal sign, circle y. This negative 2x is like I'm minusing 2x, so I'm going to do the opposite and add 2x. Total everything up. That's 0. I'm left with y is equal to. Now I want to make sure I write it in slope-intercept form. So if I write 6 plus 2x, I need to rearrange it so it says 2x positive, since it's plus 2x plus 6. So what does this information tells me? It says start at 6. 2 over 1 is my slope. Remember, that means I move up 2 into the right 1. So putting that information together, start at 6, up 2 into the right 1, connect my dots. There's my graph. Now let's graph our second line. Now this one's already solved for y, wahoo. So now I just have to find my information. So I'm going to start at negative 1, and this 1 over 4 tells me to move up 1 and to the right 4. So starting at negative 1, up 1 and to the right 1, 2, 3, 4. I'm going to extend my line in both directions. And I can see my intersection point is going to be right here at the ordered pair negative 4, negative 2. That is my review. If you have any questions or struggling on any of those problems, please let me know. We can schedule a Google Meet. Have a great day, and we'll talk to you later.